We're going to walk through using Eucalyptus to create a Linux virtual machine. We'll use that machine then we'll log into it and use it to deploy a Node Express app. So let's walk through that. First thing we're going to do is just log in to the amdahl.cs website using the credentials you should have received in an email. Upon first logging in, you'll see a dashboard similar to this. And most of our work will be done in the upper left-hand portion where we will be creating and managing our virtual machines. To create a virtual machine, we'll launch a new instance. I would recommend the Ubuntu OS. And I'm just going to name this CS 402 tutorial. I'm going to configure this machine with one CPU, 2 gig of memory, and a 10 gig hard drive. Now these are virtual things, but they do consume resources on a real machine. So in other words, never use the larger CPU categories. That's all for this screen. We'll punch forward now. It will ask you, you are required to use a key pair to create one. I've already done that. I did that in class. I'm not going to repeat that process here, but just recall that when you create a key pair, it will give you your credential file, and it will immediately forget it. You'll need to download it, save it, and ensure that its permissions are set correctly to be very secure. SSH requires them to be. In the Unix world, the permission setting is 0400. Create a security group, and that's effectively a firewall for the virtual machine you're creating. When you create the security group, allow access to port 22, which is SSH, and also open up port 3000, which grants access to Node Express applications. Now that's really all there is to it, and we'll create the machine. So we are booting up a virtual machine on the cloud. The status is pending, meaning that it's in a sense the boot up state. It's not quite ready to be to receive connections. The public IP address is given here, and once it's ready to go, we're going to use SSH to access it using the key file that we earlier downloaded. That key file, you might recall, serves as our login credentials. So I'll move over to a terminal window. I'm using OS X, and I'll prepare to connect through SSH. There's my credential file. I've saved it earlier. The root user is named Ubuntu in this installation, and the IP address will be the .177. Okay, it looks like that machine is running. Let's see if we can now connect to it through SSH. Okay, so it seems to be functional. And we are now logged in to a virtual machine on the web. I'm no longer executing code on my laptop, but rather executing code on this virtual Linux box. Now, there's a one-time setup cost. Once you've created this machine, and by the way, you only need to create one machine for the whole semester, hopefully. Depends on some of the things we do later, but you do have to go through a configuration step to get it up to speed. The first thing I'm going to do is I'm going to update this machine, sudo apt update. Now, update doesn't actually do anything other than download new lists of the most recent packages available. Okay, it doesn't actually install any packages. It doesn't update any packages. It merely gets a new list of available packages. Now the next command, however, will be more lengthy. The upgrade command, sudo apt upgrade, does in fact take a look at all of the packages that are installed on this machine, looks for updates to each of those packages, and then pulls them in and installs them. So this again is a rather lengthy process because it will update every package that it knows about. Now you might think, wow, this is taking so long because my laptop is slow, it's old. Perhaps you have an older machine and think that maybe it's running slow because of that. But just remind yourself that nothing is actually taking place on your local machine. Rather, all the code is executing on the virtual machine that we just created. Okay, so now our machine is effectively completely updated to the latest versions of all the packages that exist in the Ubuntu world, okay, at least that are installed. Now, what we're going to be doing here is now we need to prepare it for our use with respect to web development. So what I'm going to do is, first of all, go about installing Node.js. Now, Node.js actually is a fairly small package. Sudo apt install Node.js. I'm going to install it. It consumes, it says here, 31 meg of memory. So Node is now installed. Now, in addition to that, we will be using the Node Package Manager NPM. So I'm going to install that too. Now, this package manager is actually quite big and will take somewhat longer than installing Node. So it must have a large and deep dependency tree. It's grabbing all of those packages that it relies on and installing them. I'll just remind you, this kind of startup cost is incurred only once. With any luck, you can use the same machine for all of the homework assignments that you'll do in this class. Now, once NPM is installed, we will then use get to clone a package, a project from GitLab, so that we can actually execute it on this virtual machine. So let me get prepared to do that. This is one of the publicly available projects that I have installed on GitLab. I'm going to select this URL that will allow me to clone it once we are ready to do so. Okay, so I believe now that we are finally ready to move on here. So, what I'm going to do is clone that project. And so there we go. Now in class I had difficulty with the git clone. I'm not entirely sure why. Because with a clean new install, we are good to go. I didn't need to do anything else. Now maybe it was just the fact that on the GitLab site itself, once I created a token, I was good to go. I'm just unclear on that, but nonetheless, it works for me now. Okay, so I've got the package or the project installed, the to-do application. So let's take a look at that. That's a Node Express application. It's actually named to-do1. So there's the application itself. It has the correct file and folder structures for an Express application. Now, the next thing I'm going to have to do is install all of the dependencies that this package relies on. So npm install will get that job done. Then I can npm start that application. So this application should now be accessible through the public address, the public IP of that server using port 3000. And there we are. We are actually running that application on that virtual machine. Now the thing about that is if I were to close this terminal window or turn my computer off, there might be problems with respect to what happens to that application. The application would itself be terminated because it's connected to this terminal. Once the terminal goes away, the server application goes away. So you really can't run it as you deploy it permanently through npm start. What you really should do is use nohup, which means don't hang up when the terminal hangs up. And let's put it in the background with the ampersand. The ampersand here means run it in the background. So once I do that, now the application, the server is running. The server is in a sense no longer attached to this terminal window. That's what the background process means. Okay, so let's see if it's still running. It is. And even if I were to log out of this window, okay, so now I'm back onto my local machine running within that terminal window. This application, the server, should still be functional, and it is after refresh. That's all we need.